All right, since most of you all have completed your project, we'll go ahead and look at project 2. All right, project 2 is going to be a little different. I'm not asking for performance in this one. I'm just asking for you to be able to do it. Okay. So a little different. It's actually, I actually consider this one the easiest of the projects. Because you don't have to worry about performance. You just have to make it work.
It has basic.
It has what? It has the word basic up there. How bad can it be?
HTML, which is an entirely different language.
Okay. Who here has not done HTML?
Oh.
Wow, okay, so there actually are a couple people. Okay, all right. Well, it's not too complicated.
Oh.
The hard part of this is actually learning how to build up your parser and getting that working correctly, and then solving the problem afterwards is, well, I don't think it's too bad, but that's just my opinion. I've only done this for, I don't know, over decades. But anyways, we're going to build a simple HTML parser and determine if HTML tags are balanced. So we'll go and talk about that. That's the first part of your project. The second part is finding the number of web pages you can visit from a certain HTML page. So not just the number of links inside that page, but you also need to go to each link inside that page and figure out what pages that can go to as well.
This does not sound kind.
Hmm?
This does not sound kind.
This is
It's not.
easy. Compared to your last project, this is not bad.
The way you said that.
Are we sticking those files in our directory as well, or is this like we're going online?
You're not going to go online.
Okay.
I'm going to simplify this problem. You're not going to be doing real live web pages. Sadness will occur.
Yes.
Okay.
All right. It is important to know your HTML tags are balanced. For example, here's a very simple HTML code. For those of you who haven't done HTML before, let me go ahead and show you what's going on. Notice that you have a begin tag and an end tag, where the begin tag is just the name inside of a less than and greater than sign, and the end tag is the same thing but begins with a slash or a forward slash. What this is signifying is that everything in between these two tags is contained within whatever this is. In this case, it's HTML. We're saying HTML is between these two, the begin tag and the end tag. We have body. This is defining what the body of the HTML page is. Because if you do HTML, you have the body, which is your web page, and you can also have the header or the title bar, which comes up on your web browser. So that's cool. So the body is saying this is going to be contained in the body, aka what's being viewed. B means bold. So whatever contained in here, make it bold. I write hello world. So this should just be a web page that has in bold hello world. All right. This is balanced because every end tag matches perfectly with the begin tag, or vice versa. At the same level depth, or so to speak. And I have it tabbed out or spaced out for you so it'd be easy to see. Oh, you have a question? Okay. The second one is not balanced because if you notice, the body tag tries to end the bold tag. So this is wrong. This shouldn't happen. Actual web browsers are still going to try and figure out what to do with it, but if you were to be a strict web browser, you would throw an error saying this is not legit. So we are going to first find out, is an HTML page balanced or not?
So basically, you have to find whether, like, if you stumble upon an ending tag, and if the ending tag is not for the tag which was last opened, then it's
not balanced.
Otherwise, it is.
You got it. But you got to make sure. The other thing is that you got to run through it, and everything has to be balanced. Like if you didn't have this HTML down here, it would be unbalanced because nothing ended the HTML page.
So by the end of it, you have to have no tags which was closed.
Right. Exactly. You got it. So the above is not balanced because the body tag is ending the bold tag in the following basic HTML definition. Your job is to determine if a given piece of HTML is balanced or not. Okay, what I'm telling you here is this is all I'm going to throw at you. I'm not going to make it any more complicated than this.
Thank you.
You're welcome. In the beginning, you have HTML beginning and end tag. We're not going to have anything else. Inside of body, and inside of HTML, you have body. Notice I have an all caps body, which goes down to the next rule called body. And there you have body with text in there. Now, Once you go to text, that's when things start to get somewhat complicated. Notice text can be a string, or string text, a tag, or a tag text. Notice that text can have more text inside of it. All right, what does that mean? Well, string can be empty, or some other characters that are not less than a greater than, aka hello world, or hi, my name is whatever. Or you can have more text if you want it, or you can have a tag or a tag with other text. So what's a tag? Well, that's what we're talking about. A tag can be a bold tag, an italics tag, or a link tag. So a bold tag is right here with B, beginning bold, or you can have italic ones as well as link inside of it. Notice that you can have bold and italic and link tags inside of each other. A link is going to be the only one that's going to be a little weird for you to parse. A space href equals URL. The URL is telling you where the next page is located. Of course, text with a backslash A. And URL is just a string. I'm going to go through a little more with parsing later, HTML page. But notice that example HTML pages are in your pages directory of your project too. Specifically, let me put that to the background. If I go inside of pages, ls, I have different ones. So I can index, here we go. That's an example page. What do I have? Not balanced. So I have an example of one that's not balanced as well. And there's other ones to view as well if you want to. So step one is to find out if that is balanced or not. I have given you example code, or at least something to start with. For example, if you type make, or maybe I don't, oh, it's in pages. Make, then I can try and run the HTML test, and currently it does nothing, but that's because you have to send it all the files. So if you do HTML test pages / star, it's going to send it all the files in the pages directory. The code is not done, so you have parsing. It parses the pages and then tells you if it's balanced or not and what it can visit. Obviously, this is not correct, but this is just something to get you started. This is how I've set up the code to start presenting the project. If you were to look inside of it, do you have a question? No. We'll go back to the code in a moment. I just wanted to show you how it should be presented. But notice that there's a parsing routine. I'm going to allow you to parse the HTML first, and then later ask if it's balanced, and then ask how many pages it can view. Yes?
Do you want the total at the end though of all pages?
No. Okay. So part one, I let you parse it, and then I'm going to ask if it's balanced or not. Okay. Part two, web crawler. Now that you have a basic parser, write a web crawler to determine the number of unique pages that can be visited from a certain page. Keyword there is unique. If you have a circular reference where it goes back to itself, you don't add that again because you only want to know how many unique web pages you can visit. Okay, so see below. Huh.
So, are the links only to other web pages in the folder?
Right. So here's the example of a run. So what do I have? Pokemon. At the time, the students really loved Pokemon. Pokemon, notice it has one link to the end. If I were to open up the end, it has nothing, the end. So Pokemon can only visit one web page from itself, right? But I have an example here of index. So let's go ahead and look up index. Notice index can go to Pokemon, so that's one page, but then Pokemon can go to another, so that's 2 pages, and then we're done. So in that case, you have 2 pages that can be visited from index.html. Y'all see what I'm saying? All right. And it's telling you also here if it's balanced or not. This is the correct output given this command line up here, which is what I ran earlier. A couple other things, because when you go into this, there's going to be a couple of gotchas. Well, there's an explanation actually. The end has no links, so its count is 0. The end is 0. Not balanced says no links because it's not balanced. If a page is not balanced, you assume there are no links in it. Once it's determined not balanced, don't try and parse it for links. Okay? Pokemon can visit one page, the end, which is valid, and a dead end, so it has one. And as I just said, index can visit 2 pages, even though it has one link. It can go to Pokemon, which is valid, and then it can go to pages to the end, which is also valid. Keep in mind, we want the number of unique pages. I don't have an example here of a circle, but if the end somehow went back to index, at the very end of it, index should still only print 2 pages because you can go to Pokemon the end, and just because you can go back to yourself doesn't mean anything. It's not unique. Any questions on what I'm asking for in part 2? All right. Parsing. So part of this project is with parsing. Also part of this project is demonstrating your ability to figure something out on your own. So I'm going to give you some hints with parsing, but you're going to have to try and research it and figure out how to do basic parsing on your own. I've tried to make the parsing as simple as possible for you. Tags are going to begin with a less than and end with a greater than. They do not have a less than or a greater than between the starting or end tag. That is a huge help. Once you see a less than, you should write a routine to parse it all the way till you see a greater than, and that is your tag. Right, there you go. All tags except the anchor tag will have no attributes or white space. That means there is no space in here. If it doesn't begin with an A, you're just going to keep parsing all the characters, and what's in between that less than and greater than is your tag. So there's nothing, no fanciness. You don't have to do any trimming on that in that regard. The anchor tag will strictly be in the format of A space href equals file name. There's a space between the A and the H, and it's in specifically this format. There's no extra white spaces. There are no quotes around file name. It is just directly the file name right there. This is again to help you with your parsing. If you encounter a tag that is not valid, then the page is not balanced. So if I decide to throw in the paragraph tag, you say it's no longer balanced. I will ensure all tags are lowercase. To ignore white space, parse everything one character at a time. This is the biggest thing I can do to help. Parse it one at a time, create a string object, and only add characters to it as you see fit. But ignore a space, a tab, and a new line. That is space, \t, \id, and \r. Ignore all those characters. Okay. I've made some code for you. You can look at it run. Those are the commands, make, and then HTML test on pages if you wish to do some manual tests. Ooh, that was a big jump. You are in charge of reading the source code and figuring it out. Part of this class is starting to go from, instead of me hand-holding you through code, being able to actually read some code and figure out what it's doing. So the code is spaced out. It may not be as commented as you would like, but it should be readable. And if you need some extra help, definitely go ahead and look online about what the STL is doing. I'm trying to see. I don't think it said it's going to help you in this one. Yeah, there are. So far we've used arrays, linked lists, pointers, stacks, and queues. You may use those 5 data structures. You may even use them from the STL. Don't use map, don't use set, don't use other things as well. You can use algorithm with sort if you think that's going to help you. I don't see how it's going to, but sure, why not? Stick it to the man. Chances are you'll be using more than one data structure to solve this problem. That is a big hint. But you only need to use the ones listed to solve it. If you're familiar with STL, you may use vector stack queue from the STL, but don't use anything else. You can use something from algorithm as well, and that's okay. And if you want me to do speed and memory results, I don't think it's going to be that big here. You can go ahead and give it the code name, but chances are I'm not going to do this graph because I haven't found too many unique solutions. This is really getting it coded and getting it working is more of what this project is about than anything else. Again, data structures are significantly more demanding than your labs. Have y'all, that's a what? Hopefully you've encountered that with Project 1.
Yes.
All right, everyone good with me on this?
Yes.
All right, good. Please start early. Please come talk to me if you have questions. You need to figure out how to solve this. It is a good idea to think about at a high level, once you get the parsing down, how you're going to proceed with solving these two problems. If you come in without an idea, I will tell you to keep thinking about it. Keep in mind there are many good, fair, and terrible solutions to data structure projects, and that is true even on this one. Part of this will be how well you write test cases. You'll be in charge of all test cases. You turn it in via GitHub. I think I made it 3 weeks minus a day. That way it'll be due the Wednesday before the next class. That way, once you turn it in, you'll have at least a morning where you won't have a project assigned. Right? Okay.
Wednesday morning? Is it Wednesday?
It'll be Thursday morning before you come to class, because the project would have been due last night at midnight.
Oh.
And then, so you'll have from there till about,
We get a day less.
yeah, you get a day less. That way I can help you.
Can we integrate faith and learning and show some mercy?
I need to pull out Proverbs as well. Show mercy. Any other questions?
God wasn't very much about the mercy back in the Old Testament. He was not about the mercy.
Right.
You get more, getting more like the bears and stuff. Being lost in the desert for 40 years, that's pretty unmerciful.
Yeah, we're letting people lay this
Any other questions, comments? Screams? All right, guys. Well, go ahead and get your project 1 done, and then you can start thinking about project 2.